G'day and welcome yet again. This is the third video I'm putting together on the art of counting, the art that we call in mathematics combinatorics. We start, of course, as children, learning to count 1, 2, 3, 4, 5, counting objects 1, 2, 3, or whatever. Counting our friends, counting our money, counting our books or our toys, or the number of peas on a plate. It really doesn't matter. We learn to count, and children enjoy it. It's a wonderful skill. It gives a sense of accomplishment, a sense of power, if you like, that we can say there are so many objects there, and these over here are more or fewer. And in the previous couple of videos I showed how mathematicians have taken that a step further, because we don't just count objects, but we count possibilities, or we count the way that objects can actually be arranged. You know, if you put in stamps in a stamp album, how many different arrangements can you do if you don't care too much about the order? If you have 5 stamps, how many ways can you arrange them? Turns out to be 120, and you have to look at my previous 2 videos for that. But this particular video, I want to talk about a game that I was introduced to when I was in primary school. I didn't enjoy learning this game. Some child came up to me and said, "Would you like to play," because we'd been doing something with cards, I can't remember what it was, and the student said to me, "Would you like to play 52 pickup?" And I'd never heard of this game, 52 pickup, and of course I said, "Oh yes." Whereupon they grabbed the pack of cards and threw them in the air, and they went everywhere. Why is it called 52 pickup? Because as that student walked away, he said, "Pick them up." And there are 52 cards in a pack. It's a bit of a cruel game, cruel trick to play on someone. But because there are 52 cards here, he threw them up, 52 cards to pick up. Enough said. That stuck in my mind. I didn't get caught playing that game anymore. But here's an interesting thought. I'm not going to get to an answer here because I only just thought of the question a matter of minutes ago, and I thought it'd be interesting to share with you some thought processes about this. What if you did throw them a pack of cards, so they absolutely scattered the winds and landed, and you wanted to know how many different sort of arrangements there might be on the ground? That's a staggering thought, just randomly fluttering down. I want to suggest this to you. Let's start with 2 cards. Now, let's imagine they land like this. Here's one card and another card lands here. We've got to first of all define something, or explain, or at least come to common agreement about what an arrangement might be. Are we too concerned about whether we're standing on this side or whether we walk around and stand on this side? In other words, are we worried about if this is a 2 and this is a 7 card? Are we worried about whether the 2's on the left of the 7 and the 7's on the right, or whether the 7's on the left and the 2's on the right? So in other words, does it matter to us where we're going to stand, or are we just concerned with how they land on the ground? And if we agree that we're just concerned with the arrangement on the ground and not with where we stand, we would call that one arrangement. So 2 cards, one arrangement. And I'm not too concerned about which way the card's oriented or whether it's flipped over. It's just its position. When we bring a third card into it, I want to suggest that there are 3 possibilities. chose it. Here we go. Here's a jack. The jack could land on this side, anywhere on this side, so it could be out here, up here, or somewhere. But imagine if we just drew a line between the 2 and the 7. The jack could land somewhere on this side, or it could land somewhere on this side, or it could land on the line, and we might make a distinction between at the 2 end or the 7 end or in between. So we could actually have, if we're thinking in these terms, 5 possibilities, couldn't we? On the line here, on the line here, on the line here, because they're 3 distinct parts of the line, or just in this region here or this region here. Now I'm going to simplify the problem so we understand it a bit better. Let's imagine we discount, we're not going to worry about cards lining up exactly. The chances of that happening exactly are extremely slim anyway, because if you measure down to tenths of a millimetre or something, or hundredths of a millimetre, I think we can agree that the chances of cards lining up absolutely precisely are just vanishingly small. So let's just consider a card landing this side or this side. So how many possible arrangements do we have when we have 3 cards drop? Well, there'll be that possibility and that one. So we have 3 cards with 2 arrangements. Now let's imagine the jack lands here. We're just looking at one of these possible arrangements at the moment. And then we throw another card down. What have we got here? A 9. And we're not going to allow the 9 to land on any of the lines between the cards. Where could the 9 land? Well, let's have a look. The 9 could land, where is it? This is it. It could land here in the triangle between all 3, couldn't it? So on the right hand side of this line and above this one, and on the bottom left of that line. Or it could land out here, so it's on the other side of this line, that's in a different position. Or it could land over here, here. So you see we have some regions now for this card to fall in. How many of them? 2, 4, 6, 7. So if the jack was here, there are 7 possibilities for the next card. And if the jack was on this side, there'd be another 7. So we're now up to 14. 14 arrangements. I think you see too that dividing the plane, the surface, into regions is important. Now for every one of these, if, for example, the other card landed here, we would have all these regions, we'd have to draw lines between these, and we'd have to total the number of regions. Now there's a formula, there's a method, and I've actually produced a video on this earlier, about the number of regions. It's in the, if you look it up, it's on the Babylonian differencing. So just look for Babylonian differencing and look at some of my videos. And it's the ways of dividing how many different regions is a plane divided into by a certain number of lines. And the number of lines you can work out from the number of points fairly easy. It's a fairly sophisticated question. And you can see we get lots and lots. So by the time you get to 4 cards, the number here is quite substantial. You can now appreciate why I don't want to go to 52 just at the moment. But for those of you inclined to explore this, and it is a challenging question, I encourage you to give some thought to how many lines you could draw through 4 points, or through 5 points, or through 6 points, where none of them are lined up. That is where you haven't got any 3 collinear. And once you have that number of lines, how many regions the plane is divided into. And see if you can deduce what this next number is. I'm not going to give you an answer. See, real mathematicians. I was just thinking about this recently. I was talking to one of the students I tutor and the student's parent, and talking about the fact that often when I've collected puzzles over the years, and many of the puzzles that I collect I don't keep the answers to. Now, it might sound a bit strange, but if I have the answers, it discourages me from thinking. Whereas if I don't have the answers and I need, in essence, I'm collecting questions. And to me, the questions are vastly more interesting than the answers. The question, how would you go about answering the question of how many arrangements of cards, how many different ways could the cards fall? And I'd be curious to see any discussion under this video about this number. And then, of course, that's actually the hard step. Once you've got that, you start to develop a principle, and you can probably work out the next one fairly easily. And by then, you might even be able to predict, if you're very clever, what you would get as a combination for 52 cards. And I think you will be absolutely staggered at the size of the number. I mean seriously staggered. It is an amazing problem. Now, I haven't fully investigated it myself, so I don't even know the answer, but I do know the nature of what's happening here, and it is extraordinary. All from a simple pack of cards, and all from, little did I realise when that student played the trick on me all those years ago, 52 pickup, what it might lead to. How many ways could they have actually fallen? Interesting question. And that's the combinatorics question. How many ways? How many? How much? How many arrangements? I hope that makes sense to you. This is just a branch of mathematics. Mathematicians wonder about how things can be arranged. Let me encourage you to Google the term combinatorics. Look it up, read about it. It may not be exactly what you're interested in, but if you're at school, you might find that this will intrigue you, and it might even become a passion, and perhaps even a lifelong quest. The world needs more people who count. I hope you've enjoyed that. If you have, please click on the like button. Please leave a comment. I enjoy your feedback, and certainly if you've worked on this, I'm interested to see what people share. And if you would like to hear about future videos and you're not a subscriber, then please click on the subscribe button and join the merry club. And as always, I thank you very, very much for watching.